continued from yesterday. It shouldn't take more than a few minutes, 5 minutes or so to go through this. I just talked to you guys about the word derivative. A derivative. Now yesterday I changed this. No, I didn't change it. I forgot to rescan it. I'm sorry. This definition right here I want you to get rid of. Please cross this off. I changed what I was going to have it read. And what I would like you guys to have it say now, instead of what was already written in your notes, is I would like you to say that it is the limit used to define the slope of a tangent line. The limit used to define the slope of a tangent line. The limit used to define the slope of a tangent line. So you know what? I told you you were going to learn a new word today, but you weren't going to learn anything new. And what I meant by that was that a derivative is like a fancy way of saying that you are going to find the slope of a tangent line. So all I'm doing is teaching you a word today. Derivative means you are calculating the limit as the change in x approaches 0 of f of x plus the change in x minus f of x divided by the change in x. This thing right here is not new to you. You learned this yesterday. The only thing I'm doing is adding the word, and I'm changing the notation. Do you see this? F with the little mark right here is the notation that you can use to represent the derivative. So the derivative of a function is equal to the limit as the change in x approaches all of this stuff. Okay? New notation. If you're finding the limit, if you're calculating the slope of a tangent line, this is the notation that you use. G of x is equal to x cubed plus 2x. Yesterday, I had you guys get out a sheet of paper, and I had you write down what is x plus the change in x squared, what is x plus the change in x cubed. Remember that sheet of paper, that extra sheet of paper? Yes. All right, so get that out, please, because look what you need to do. X plus the change in x to the power of 3. That, it gets long and tedious. That's why I said do it once, have it written down, put a box around it, and refer back to it every time you need to do it. So, you have x cubed plus 2x. What we're going to do to find the derivative of this function, which just really means I am calculating the slope of a line tangent to this function, you need to replace the x here with x plus the change in x. Cube it. Plus 2 times x plus the change in x. Are you okay with that? Mm-hmm. Nothing new. Minus the original function, which is x cubed plus 2x. All divided by the change in x. So what I did next was I actually did this, x plus the change in x cubed, and I said go ahead and get out your notes. Write down what your notes say. And your notes say that x plus the change in x cubed is the same thing as x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed. It's all of this stuff. Okay? And then you're going to distribute the 2 in, getting you 2x plus 2 change in x. I distributed the 2. And then I have to distribute the negative sign in, getting me minus x cubed minus 2x. All of this divided by the change in x. And then you start canceling things out. So these x cubes cancel out. We have a plus 2x and a minus 2x that cancel out. You with me there? I'm going to delete here in just a minute and scroll up. Yeah, is that what you said? Slow down.
Wait, so the x plus the change of x cubed, where is that?
This right here, x plus the change in x cubed.
Yeah,
Well, I had done all of the math on a separate sheet. Okay, I'm just saying that this part right here, all the way up to here,
that's not that.
is what I came up with after I collected like terms and everything else. Okay, so this is the end of the story right here. There's a lot of math that goes into that. 2x to change in x minus x cubed minus 2x. Okay, are you okay? Okay, cancel things. I didn't know if you said scroll down or slow down earlier, so okay. All right, so here we go. That leaves me with, after I've canceled everything out, that leaves me with 3x squared, the change in x, plus 3x, the change in x squared, plus the change in x cubed, plus 2 change in x, and those were just my leftovers, and I combined them and made a rule divided by the change in x. All right, now, what I did now was I factored out my change in x, and when I factored out that change in x, those canceled out, and it just leaves me with 3x squared, which I have here, and it leaves me with, I factor one change in x out, I'm still left with 1, and I also have the 3x out front. If I factor one change in x out of that, I'm left with a change in x squared, and I factor a change in x out of this, I am left with just a 2 right here. That's where that 2 came from. And now remember, anywhere that you still have a change in x left, you go in and plug in a 0. So you put a 0 in here, you put a 0 in here, it leaves you with 3x squared plus 2. This is the slope of the tangent line, which we now call the what?
Derivative.
The derivative. Yep. Nothing's new, just a new word. Okay? Alright, I'm done.
So when we're on